Hello and welcome to another Advent of Code Solutions, and today we're going to be doing day 2 of Advent of Code. Again, if you don't want spoilers, this is not the video for you, but let's jump into it and show you exactly what day 2 is about and how I solved it. So again, we're going to start with a simplified version of the description. And the description of the problem today is we are going to have input as a series of password rules, which have a number, a dash, a number, followed by a character, and then a password. And the puzzle that we're trying to figure out today for part 1 is to find the number of passwords which have a count of that character between the first number and the second number, which I called beginning and end. In part 2, we're doing the same input, same kind of parsing rules, but instead we are finding the number of passwords which have that character at either the first or second position. And again, to note here, the positions will be one index, so we're going to be off by 1 in Python, but other languages are 1-based indices. And the other thing which a lot of people tripped up on is this is exclusive OR, so it has to be one or the other, but not both. So let's start by doing the parsing part, and I have set up a little bit of a class here today to make this. Oh, let me actually put this on the other screen. I've set up a little class here to make this a little bit easier to think about and like reason about here. Oh, and I should have said that this returns a list of password. Originally I was going to do this as a tuple, and then I was like, wait a minute, we could use a name tuple and make this a little bit easier to understand. But again, like the other puzzle, we're going to split the input into lines. So for line in s.split lines, and we are going to parse out. We're going to parse out our password from here. And when I saw this problem, I intuitively thought, oh, this would be a nice problem for regular expressions. I did a video on regular expressions. I will try and remember to link that in the description. But you can actually implement this parsing without using regular expressions, which is what I ended up going with. So if you were to do this with regexes, it would look something like port RE. You would want password word RE equals RE.compile. Rostering probably, yeah. And some number of digits followed by a dash, followed by some number of digits, followed by a space, followed by a character, followed by a space, followed by the rest of the password. And so you could parse, each of these individual parts into their fields here. I'm actually going to show you a solution which doesn't use regular expressions because I find that it's a little bit more intuitive for me. So the first thing that I did is I split this line into 3 different parts. So part 1, part 2, part 3 equals line.split. Now split is nice. This function is actually kind of amazing. If you don't pass anything into it, it splits on any white space. In this case, we just care about spaces. But we'll actually use this in a later day to split on new lines as well. So once we've split it into 3 parts, part 3 is already our password, so we don't need to do anything to process that, but we do need to split this apart. So we have start S and end S. Actually, I like to use partition. I have a video about that, so I'll link that in the description as well. Part 1 dot partition on the minus or the hyphen. So that should get us our 2 strings. We need to still convert those into integers, but we're pretty close there. And then finally, we need to retrieve our character. The character is always going to be 1 character long, so it can just be part2 0. And so if we combine all those together, ret.append, and then we build a password with int start s, int end s, part 2 0, and part 3. That'll actually probably fits on 1 line, so we can probably just do it like this. And so that'll build up our passwords and return ret. And if we run this, parsing.py, of course it's kind of hard to see, so let's pretty print that. pprint.pprint, and you'll see that we have parsed out our 3 sets of passwords here, and we have the right data types. So anyway, that's the first parsing part of the problem. I found that this problem was a lot harder to parse than it was to actually implement, so if you did spend a lot of time on this, don't worry so much about that. Anyway, let's jump into part 1. I have, copied along that input here, so we don't have to, rerun that parsing again. Let's see, what was the problem description again? The description is find the number of passwords which have a count of that character between beginning and end. And this was actually inclusive, if I recall correctly. Inclusive meaning it could be exactly the same as beginning and end. And so to do that, we need to maintain a counter. So counter, or I guess a total. Total equals 0, and we're going to loop for over each of these passwords. So for password in input, and when I saw this problem and it said counts, I immediately jumped to counter. Counter is actually not the fastest solution to this, but I did a video on counter, so I will link that in the description if I remember. If I forget any of these, please yell at me in the comments. But counter is useful to take an iterable, which we have an iterable of characters here, and count them. So char count counts equals collections dot counter, and we can pass in the password dot password, and we can say if password dot start is less than or equal to char counts password dot c is less than or equal to password dot end. Then we can increment our total. Oops, total plus equals 1. And note that I'm using an interesting feature of Python here. Python allows you to chain conditionals like this. If you're working in a different programming language, you might have to write this as 2 separate if statements. For instance, like if you're doing C++. And if we talk about algorithmic efficiency here, this is basically ON. This counter is also ON over the password length, but you know, in the actual input of the problem, there are many more password lines than there are password characters, and so this is kind of diminished to 0. Now note that this is kind of slow because counter builds up a whole data structure for this, and so there's actually a faster way to do this, which I thought of after after the fact. Let me actually show that this works as well before we actually move on to password has no, oh, it's not start, it's begin, right? Has no attribute char. C, it is right, it is char. And you'll see that we don't get the right value, we get the wrong value here. Why did we get the wrong value? Well, let's debug this and see what's wrong here. So the first password, char counts, password.char is A. This should increment here. Does. Char counts for the second password. This one should be invalid because we don't have any of those there. So we skip to the last one. Char counts password.char is 0. Oh, I copy and pasted this wrong. Oh, we're gonna run into that same problem on part 2 as well. Let me fix that. Okay, so it is actually correct. My data, I just transposed the data improperly. Part1.py, and you'll see we get the value too. Cool. So that's with counter. I also did this instead of using counter. It's actually slightly faster to not use counter, and you can do password.password.count password.char. That's actually not going to fit on that line of code there, but you can pretend it's there. You can just say counts equals this, and that way it's not too long, and we can still see what's going on here. And this is kind of a faster way to do this. So compute count and compute counter. And you can see that both of these arrive at the same solution, and they are both ON. This one is slightly faster because it doesn't have to maintain a data structure here, but other than that, you know, they're basically the same solution. So that's what I had for part 1. Part 2 takes this same problem but applies a different set of password rules. And if we open up part 2, I actually felt that part 2 was easier than part 1. We just have to check these 2 indices here and see whether they are the correct value. And so we do for password in input, And again, total equals 0. And in this case, we're just checking two characters. So if password dot password, and we have to subtract one here because it is one based. Password dot begin -1. Let's see. We can just do like begin equals. I'm going to store two booleans, and then we're going to do some boolean logic here. Equals password dot char, and we have to do the same thing but with end. Now, the problem said that it has to be exclusive OR, and in Python there's an operator for exclusive OR. So you can do if begin is exclusive OR with end. That's one way you can implement this. Total plus equals 1. And then return total. And we should only expect 1 here because this one has an A at position 1. But none of these have. Wait, this one has a C at. Oh, it has a C at position, both at position 2 and 9. So this one's not valid. That's why that's there. If we run this part2.py, you'll see that we get 1. Some languages don't have exclusive OR, so exclusive OR is one but not the other. So you can implement exclusive OR in a different way. So you could say if begin and not end, or not begin and end. So that's kind of a way to write out exclusive OR but with more words. But anyway, that's day 2. Hopefully this was helpful. I put up both of these solutions, and again, this one is ON because this loop is ON, and none of this in here is interesting work. So overall, it's ON. I didn't really have another solution for part 2, so those are the solutions we get. But anyway, hopefully this was useful. I'll catch you for the next day. See you in the next one.